Good afternoon, dear colleagues and guests. Let me declare open the session of the Dissertation Council for the Defense of Thesis by Kalinin Sergei Aleksandrovich for degree of Candidate of Physics and Mathematics, Specialization 010408 Plasma Physics, on the theme Study of Processes of the Electric Gas Breakdown in the Long Discharge Tubes. According to the order of St. Petersburg University, dated July the 12th, 2019, me, Timofeyev Nikolai Alexandrovich, was appointed chairman of this dissertation council. Let me introduce the other council members. Golubovsky Yuri Borisovich, Doctor of Physics and Mathematics, Professor of the Department of Optics of St. Petersburg University. Alexandrov Nikolai Leonidovich, Doctor of Physics and Mathematics, Professor of the Moscow Institute of Physics and Technology, the National Research University. Smirnov Alexander Sergeyevich, Doctor of Physics and Mathematics, Professor of St. Petersburg Polytechnic University of Peter the Great. And in the remote mode, we have Schneider Mikhail Naumovich, Doctor of Physics and Mathematics, Professor at Princeton University, United States of America. Mikhail Naumovich, can you hear us? Yes, I can hear you perfectly well. Also, the meeting should be attended by Nikolai Zinovich Yonich, the academic advisor. According to the order, the session of the Dissertation Council is duly constituted if at least two-thirds of the approved members of the Council are participating in its session, but not less than 4 persons. Our Dissertation Council consists of 5 members. All the members are present. Thus, there is a quorum, so we can start the official procedure. Let me set forth the official procedure with a total duration of no more than 2 hours. Our previous session was much shorter. Hopefully, we will not exceed the time limit. So the procedure shall be as follows. Item 1, Chairman's summary report on the main content of the documents submitted by the candidate and their compliance with the applicable regulations. A brief presentation by the degree candidate outlining the key points of his study. Questions to the applicant strictly on his report. Speeches of all members of the Dissertation Council with their reviews stating their opinions, questions and suggestions to the applicant. Speech by the chairman with his review. Answers of the applicant to questions and remarks of members of the Dissertation Council, an open discussion, speeches of the attendees with a summary of their positions and or specific questions and suggestions to the dissertation candidate, final answers of the applicant to questions asked, a speech of the academic advisor. Oh, here he comes. An open discussion before the open voting on awarding or not awarding the academic degree to the candidate. That part shall be attended only by the council members. That shall be followed by the open individual voting and counting the votes. The results shall be recorded in the minutes of the meeting. A decision on awarding or not awarding the academic degree to the applicant and the closing remarks of the applicant. Before we start the official procedure, please switch off your mobile phones so that they do not disturb us. Thank you for your understanding. Let me also inform you that our meeting shall be recorded and broadcast online at the university website, and the speeches are being simultaneously translated from Russian into English and from English into Russian. At this session, everybody, all the board members speak Russian, and our colleague speaks perfect Russian. Let me start with my summary report. The thesis by Kalinin Sergei Aleksandrovich for the degree of Candidate of Physics and Mathematics, Specialization 010408 Plasma Physics, on the theme Study of Processes of the Electric Gas Breakdown in the Long Discharge Tubes, was accepted for defense by the order of the Academic Secretary of St. Petersburg University on the 12th of July this year. The Dissertation Council was appointed by the order of the Academic Secretary of St. Petersburg University on the same date, and I have already introduced its members to you. The applicant submitted the following documents to the Academic Secretary of St. Petersburg University. Application to the Rector of St. Petersburg University, Professor Kropochev, on acceptance of the thesis for consideration and defense, submitted on the 31st of May 2019. A review by the academic advisor, Ionization, Doctor of Physics and Mathematics, Professor of the Optics Department of St. Petersburg University. A list of 4 publications which set out the main scientific results of the thesis, including 4 publications in peer-reviewed scientific peer scientific journals, indexed in the scientific databases. A certificate of candidate examination of the 30th of May 2019, stating that Kalinin Sergei Aleksandrovich passed the candidate examination with the following results: history and philosophy of science excellent, English language satisfactory, and plasma physics excellent. Diploma on completing the doctoral course issued on the 15th of July 2019 at St. Petersburg University, certifying that Sergei Alexandrovich Kalinin was awarded the degree of researcher, lecturer, researcher in physics by the decision of the State Attestation Commission on the 2nd of July 2019. The thesis in Russian and English on paper, on the rights of manuscript and in the electronic form. It should be noted that all the documents listed above comply with Clause 12, Section 3, Thesis, Presentation and Defense of the procedure for awarding the academic degrees at Petersburg University. Sergei, you have 15 minutes, please. Thank you. Does anyone have any questions? Now, you have 15 minutes. Good afternoon, dear council members and dear guests. Today, I would like to present my thesis on the theme study of processes of electric gas breakdown in the long discharge tubes for the degree of candidate of physics and mathematics. The breakdown phenomenon in long tubes when voltage is applied to one of the electrodes produces highly heterogeneous electrical field, which is very high near the electrode and drops notably in the middle of the tube. In such conditions, an avalanche cannot cover the discharge interval, and avalanche and streamer mechanisms are not efficient. Thus, the mechanism of breakdown of low tubes is realized. At first, the primary breakdown between an electrode on which high pressure is applied and the nearest part of the tube wall. Then, ionization wave starts to spread from it in the direction of the grounded electrode. Gas is ionized and the entire tube breaks down. Ionization wave is a localized either high potential gradient moving from the high voltage electrode to the low voltage one at the rate of 10^5 or 10^10 degrees centimeters per second. The study of breakdown processes started in the end of the 19th century. And the first scientist was J.J. Townsend, who discovered glow in front moving from the grounded electrode. Later, in 1937, Beam, Snoddy, and Dietrich discovered that the movement of the front coincided with the potential front. In late 30s, in the works of German authors, established that gas ionization begins in the air, near the electrode. And in 1960s, Niederspasser and Novik articulated the modern concept of long tube breakdown. The second wave of research started in late 1980s in connection with development of lightning technology and wide use of fluorescent lamps. However, a number of issues remained unclear, and our paper is devoted to clarification of these issues. The purpose of our paper is to prove the existence of primary breakdown, the register and analyze ionizing radiation spectra, clarify the role of low voltage electrode in the initial stage of breakdown. The results of our work have been published in 4 articles, published in journals, included in WOS, and reported at 5 international conferences. The structure of the thesis is shown on this slide. The installation scheme is shown here. It consists of the long discharge tube, impulse power source generates impulses, rectangular impulses. When voltage is applied to high voltage or grounded one, this is important when we start talking about reverse breakdown. There's a registration system which we use to register voltage on the tube and light signals from 2 points along the entire length of the tube. To manage the entire unit, there's a start and synchronizing system that initiates discharge and synchronizes the entire system, power supply and diagnostics. The experiment results are shown in the next slide. With the help of this system, this registration, we registered 5 signals: voltage on the tube, currents through the anode, to which high voltage was applied, and cathode, which was grounded, as well as light signals near these electrodes. As the figure shows, at first, after high voltage is applied, then this when current appears, a high voltage is applied to, accompanied by small decrease of voltage, and current in the low voltage electrode is absent. This is followed by ionization wave, which is accompanied by the current flowing through the anode, a voltage drop on the high voltage electrode. The wave reaches the cathode, a peak current is achieved, and the entire tube, a flash of light. You may see a flash of light on the high voltage electrode, and on the low voltage electrode, high voltage current on the high voltage and flashes of light means of primary breakdown. So current is described by Nils Pasov and Novik. In case of a negative polarity of the tube, the breakdown occurs at the voltage grown front, because the heated electrode to which voltage is applied, and the picture of breakdown is the same, remains the same. Well, we have also modeled the breakdown processes, and the results prove the modern picture of the primary breakdown is accurate. So we also registered light signals along the tube. We measured the average time, average travel time, and higher the voltage, the shorter the time, depends on ballast resistance. Also, so the lower the resistance, the shorter the time, because resistance, the more detailed velocity study it proved that there decreases and the discharge spectrum of direct current in such a tube is mostly represented by mercury atom, while the argon lines of argon atom are extremely weak and hard to register. On the contrary, in the spectrum of ionization wave, there are lines of argon atom in addition to mercury atom, but even lines of ion of argon, which shows high field strength as compared to the field strength in the current discharge. So we measured strength of the electrical field in the fall, and we have calculated constants of speed of excitation of corresponding level. In a quasi-stationary approximation, the ratio of intensity of the spectral lines was calculated as a function of given electric field. And by getting this ratio of spectral lines, we calculated the field itself along the tube length, and as the figure shows, the let's move to the study, the reverse breakdown. So this study was carried out in the mixture of neon argon at pressure of 1 torr. So it all started when we decided to test current understanding of long tube breakdown. Well, the breakdown process takes place regardless of the electrode is grounded or not. Second electrode is grounded or not. So the following tests were performed to verify this statement. Voltage oscillograms on the tube were recorded. The measurements show that until the ionization wave reaches the low voltage electrode, the curves coincide well enough, and then the curves begin to diverge. Same is with the ungrounded. Same applies to the velocity of ionization wave, which coincide along the entire path of the length. So this shows the same picture, only at a shorter period. So here we have added the light signal, different time scale, and after we observed an interesting effect. After a random interval of time, a breakdown occurred, but it was with the reverse sign. So we called this the reverse breakdown. So star shows discharge in the high voltage electrode. same picture with the negative, yet the only difference is that it happens at negative voltage. The results of modeling the negative breakdown show that this is a capacity discharge, and the equations, which are very long, so we're not giving them here. The equations look the same for currents. The only difference is in polarity. Capacity of the tube wall, which was charged at the time of primary breakdown. Ionization wave. So what we believe about the reverse breakdown is true, then we should expect it to create an ionization wave, so which is for both polarities, is shown here. On the basis of measuring velocities, velocities are more or less the same. So that means this is a wave which can be registered and has more or less the same velocity rate as the wave of primary breakdown. The spectrum mostly consists of argon lines. Well, neon lines are rather weak, but in the ionization wave, you may see on the opposite contains the neon lines, as well as ion lines. The estimation of reduced intensity is that of about 100,000. So if that is true from the point of charge, so then it's possible to evaluate and measure the charge, and we see that when we apply the same voltage carried by the way of ionization, coincide at primary and secondary. The reverse breakdown completely removes the wave charge. And the two-berth grounding system acts as a conventional capacitor, the capacity of about 13 picofarads. Here it happened because a high-voltage electrode was integrated, which makes our study different from the previous studies. The results of capacity estimation show quite a good coincidence with the capacity obtained from the experiment. If that is true, then we can expect the following interesting effect. If another high-voltage impulse is applied before breakdown occurs, the primary breakdown, the second pulse will not occur either. Current and if breakdown already occurred, the primary breakdown also occurs, which in this case is manifested in the rounding of the edge of the voltage pulse, and the primary. Last chapter is dedicated. The last chapter here is dedicated. All the researchers who were working with lawn tubes. They worked in the same electrostatic conditions. So the tube was not placed in the grounded screen to assess the effect of this screen. We conducted a number of tests with different screens of different sizes. This experiment was conducted with a screen of 5 centimeter large screen. The screen current can be measured, and you may see that all the three currents coincide according to the first Kirchhoff's first law. Recorded voltage show the big influence of the screen, and the screen strongly affects impulses. Same is true about the average velocity of ionization waves. Red lines shows this dependence. When measuring velocity of ionization along the tube, it's obvious, as we can see, the ionization wave, when we have a screen, moves faster, and there's no sudden jump, which we observed in other tests conducted without a screen. This explains our measurements show, charge measurements show that even where is a screen, the charge is higher, which acts as the screen acts as a capacitator. The capacity is about 5 picofarads. Graph shows the same volt, and as a result, we proved the existence of reverse breakdown. For the first time, a spectrum of radiation of slow wave ionization was obtained, and in the mixture of we proved that until the wave reaches low voltage electrode, the breakthrough process takes place regardless of the electrode is grounded or not. In a tube with an ungrounded electrode, we detected phenomenon of reverse breakdown. We established that reverse breakdown results in ionization wave moving in the same direction. The spectrum of the wave was obtained. The values of electrical charge carried by the break measured. It showed that they are equal in size and opposite in sign. It showed that using a screen significantly distorts the cause of breakthrough, though it doesn't change their qualitative quality. The dependence of the major process has been obtained. Thank you for your attention. Thank you. Questions to Sergei? I have a couple of questions. My first question: when you studied reverse phenomena, you chose mercury and argon because this mixture is used in. What's the role of mercury? Can you comment on the role if you removed mercury, because it's all connected with large fields? So what's the role of mercury? What would change if you didn't use mercury? Yes, we believe that the field will be smaller. The wave will travel along the argon lines, and the way the charge travels along mercury, so the field in the charge is very small, even at the time of breakdown. No, at the time of breakdown is very large. And one more question I have: can you go back to the slide which shows ionization wave with and without a screen? This slide. Without the slide, black line, red line is 3 centimeters screen, and blue is 5. So 5 and 3 centimeters should be different. Screens should be different. Seems the bigger the screen. Oh, I see. I got your question. So that was quite a subtle system, which includes 2 factors. When we make the screen smaller, we get bigger capacity. When with the increase in capacity, resistance goes down. So it's so we can get more current and higher speed of the ionization wave. If we make the screen even smaller, capacity gets even smaller, then the next factor becomes effective. The same capacity should be charged. So it requires charging, and the more we charge, the lower the voltage. It lowers the voltage of the ionization wave, which decreases the results in lower speed. So this is shown at the previous slide, where you may see the dependencies. Yeah, thank you. More questions? May I ask a question? My question is of a general nature. One of your major objects is the ionization wave, the slow ionization wave. Before, many researchers studied the quick ionization wave. Can you compare these two waves? Is this the same? Are these two waves the same? Are there any qualitative? What's the qualitative difference? Of course, mostly the differences are quantitative. We mean that voltage is low and speeds are low, respectively. Speed of wave or the voltage rate. Both, because if we talk of high-speed ionization, in addition to high voltage, it has to grow fast as well. Why is that? Because if we want to start a high-speed ionization wave, but it grows slowly, and the slow wave will arrive faster than the quick ionization wave arrives. So we need to voltage has to grow really fast so that it could reach high values. So that way we can make the wave really fast. So is it true that your answer is that there is no significant difference between the two waves, and the quality, the nature of this phenomenon is quite similar? There is ionization of the electrode area, ionization, which starts ionization. Thank you. I have another. I also have a question. Dr. Golubkovsky, how Thomson observed this ionization wave in the end of the 19th century? How was that possible in the end of the 19th? That's a very interesting question. Let me tell you. The matter is, he used the same principle, used an analog recording on magnetic recording. So what do we have in video recorders? Recorders were placed on the band is wide, and the heads turn really fast, and the head increases. That's how Thomson he invented a similar structure. He placed a rotating mirror. So it was quite similar to present-day tape recorders. So that's how he was able to register such quick ionization waves. Do we have more questions? Thank you, Sergei Aleksandrovich. Please have a break. We don't have any external reviews, so let's give the floor to the members of the Dissertation Council. And let's give the floor to Dr. Schneider. Thank you for your interesting presentation. Shall I read the entire review? The thesis by Sergei Kalinin is dedicated to experimental study of glowing discharge. The length is much, in a tube, the length of which is much longer than the long discharge tube. Though such these were studied for over 100 years, the studies are still in progress. That means that not everything is clear about the physical and chemical nature of these processes. This is even more true when we talk of non-stationary stage of charge. Though some researchers studied this phenomenon since the end of 1930s. Real research started in 1980s, and well, today the knowledge of long tubes is still incomplete. These are gas charge lamps, lasers, laser compasses. So this explains relevance of the thesis theme. The thesis consists of 5 chapters: introduction, conclusion, and 2 annexes. In the introduction, the author sets the theme and goals of his work and explains its relevance. The first chapter contains literature review, includes 66 publications covering the time period of 100 years. In the second chapter, the author describes a test unit created by the author. It's worth mentioning high technical level, which enabled the candidate to achieve high time resolution. Third chapters dedicated to experimental study of breakdown processes in the argon-mercury mixture. The main result of this was evidences existence of primary breakdown between high voltage electrode and the tube wall. Such evidence was not available earlier, though it was projected back in 1960s by Spasov and Novik. Diagnosis of electric and optical signals brought us to conclusion on the existence of the primary breakdown. Another important result is getting assessment of voltage in pre-breakdown ionization wave with the help of spectroscopic diagnostics. The fourth chapter summarizes the results of the study of reverse breakdown, which happens in the tube with ungrounded low voltage electrode after impulse stops, and as the primary breakdown is accompanied by the ionization wave. This wave is similar to the primary wave, but the charge it leaves on the tube walls is with the charge is different. As a result, effect doesn't cause a primary breakdown. Another interesting result is that the initial breakdown stages, primary stages, and ionization wave happen in a similar manner for the charge tube with grounded and ungrounded low voltage electrode. This evidence this proves accuracy of a modern vision of the breakdown mechanism. Chapter 4 is dedicated to the study of how screens affect the breakdown process. This was done to prevent a possible electric impact, but it has never been studied. The thesis shows that this impact can be extremely big and should be taken into account in future works. In the conclusion, the author summarizes the results Annex 1 describes electric schemes and diagrams, and Annex B describes details of electrotechnical models describing breakdown. Have a few comments. The results show that at similar speed, the velocity of positive wave is higher than of the negative wave. Unfortunately, the author doesn't give any reasons for that. Well, other authors use the term reverse ionization, and the author does not explain what's the difference from a reverse ionization wave detected by the author and given voltage in the ionization wave, judging by the results received by the author, reaches 500,000. What will electrons run away? These comments do not affect the obviously positive evaluation of Mr. Kalinin's work. His thesis meets the requirements set forth by the degree on the order of awarding academic degrees in Petersburg University, and Sergei Alexandrovich Kalinin deserves to be awarded the degree of candidate of physics and mathematics, specialization 010408 plasma physics. Thank you. Thank you, Mikhail Naumovich. The next speaker is Dr. Smirnov. We don't have a review by Alexander Sergeyevich. Have printed review that he could read. Just in case. I will not repeat my colleague describing novelty of the thesis. I will focus on some comments which I believe are, which I consider relevant for this work. The first, when modeling breakdown, capacity and resistance are used as adjusting parameters, yet capacity can be calculated quite accurately, especially for the tests with screens. Resistance can also be measured by measuring the electric field at the wave front. And secondly, the thesis describes only electrotechnical breakdown model. Would be interesting to model the physical processes. That's it. Yet, these comments by no means are not critical, and the overall impression of the thesis is very positive, and I think the thesis meets all the requirements applicable. Thank you, Alexander Sergeyevich. Dr. Alexandrov. I will not read my review, but I would like to dwell a little bit on the contents of the thesis and on the main results achieved by the author. Relevance of the theme is obvious. Quality of results, study of the ionization wave, and proof of breakdown between high voltage electrode and the wall next to it, and of course characteristics of the ionization wave. It's certainly important that the author measured the given electric field in relation to the spectral lines, the intensity of spectral lines, the different thresholds. And here, Alexander Sergeyevich already mentioned it would make sense to create a model. Well, start modeling from the very beginning. Of course, well, modeling will be easier if we were able to measure those electric fields, and so that is why we could not measure ionization field, and modeling will be much easier if we use this data. So what about reverse breakdown? This phenomenon is of course for the other conditions. It's we know it quite well. In Russian literature, in English we sort of return stroke. So on the one hand, this phenomenon is well known, and on the other, it's quite new, and the results are quite interesting. And final result, this effect was well known, and the author used his own approach to study it, to show how and where it's relevant and important, and how metal items nearby. So we have no screening what will happen with or without screening, the effect. And as for critical comments, I had some comments. First of all, speaking of breakdown, the leg time changed randomly, so it will be interesting to discuss which processes affect this random effect. We obviously here we are talking about the primary electrons. Where do they come from in case of positive polarity? Will be interesting to know the same about the reverse breakdown. And one more. So it was described, the author describes some tests but doesn't explain the results. The ionization wave slowed down, so velocity went down, but as it got closer to the grounded electrode, the speed started to grow. So it would be interesting to understand why this happens. And so these comments, of course, do not affect the results of the work which has been accomplished at a very high level. The results have been published in respected journals, scientific journals, and the thesis meets the requirements applied to such works, and the candidate deserves being awarded the degree of candidate of physics and mathematics, specialty 010408, plasma physics. Thank you. Thank you, Nikolai Leonidovich. Yuri Borisovich, it's your turn. I will not bother you with listing the achievements of the author. I would like to complement a high experimental level, a systematic approach, and detailed discussions which make very good impression. And of course, I will focus on the on criticism, which I'd like to present as questions. My first questions are all related to spectroscopic measurements. What explains discretization of emission data of separate spectral lines of the ionization wave? How do you explain the non-synchronous start of different spectral lines when recording the ionization wave spectrum? And why, when conducting tests with ungrounded electrode, why did you use ballast resistance? So these are my 3 questions. I would like you to clarify. The thesis meets all the requirements. The candidate demonstrated high qualification, certainly deserves the degree of candidate of physics and mathematics. Now it's my turn to read my review. I will not read the entire review. I think the work has been presented and discussed in detail. I will join Professor Golubkovsky that careful approach is on the highest level with the applicant, and when students come, we always take new students to Nikolai Zinovich group to show them what a well-organized group looks like. And I know Sergei Aleksandrovich quite well because Nikolai Zinovich told me earlier about the works of his students. Irim and Sergei Aleksandrovich presented his own works. So when you know the work so well, it's quite hard to come up with questions or comments. So in reality, I don't have any serious. The language of the thesis is very good. The phenomenon is being discussed from every possible angle, and I think this is the thesis is wonderful, and Sergei Aleksandrovich deserves the degree of candidate of physics and mathematics, specialty plasma physics. Thank you. Does anyone else want to speak, give any comments? Don't have no one. Ionization, the academic advisor, so we can have this discussion later if you like. If no one here wishes to speak, let's give the floor to the academic advisor. I will not go into the details of the work in my review. I would like to explain why all council members comment on the high quality of experiments. The reason is very simple. Sergei Aleksandrovich graduated not physics department. He graduated from Electrotechnical University. That's where his good understanding, good command of radio technique comes from. That's where his desire to do everything on a very high professional level. He from the very start, he was against using one-time devices or building one-time devices. I would be sometimes I would be angry with him and argue with him. I would told him that these measurements we need for 1 week. But everything he created works today and will continue working tomorrow. This is a wonderful talent of Sergei as a tester, as an engineer, as a person. He never takes anything for granted. We discussed how to build equipment, but in over every scientific point, he always asked why, and we always had a discussion. And these discussions were very useful for me because I was able to understand to what I teach better. and for our project as well. It was very beneficial. He's very passionate about what he does. You were able to see this, and it's interesting where this passion and energy come from when he started talking about this revolving mirror. You see he's an engineer, you see he's very passionate. And after some time, I'm very happy that after some time he got very interested in this work. Well, many measurements we were taken just because Sergei wanted these measurements to be performed. That is why, and in my opinion, the thesis is very interesting for gas discharge physics. The key tests he conducted, how currents at different ends of the tube and what's their relation between them. Surprisingly enough, nobody has recorded this before. It seems to be an obvious thing, but these measurements have never been taken before. So I think the results are very interesting, and the thesis itself, in my opinion, deserves their degree, and the candidate, Sergei Aleksandrovich, as the author, deserves their degree. Thank you, Yuri Zinovevich. It's my second time as the chairman of the council, and of course I can make mistakes. So now I want to give the floor to Sergei Aleksandrovich and let him answer the questions of his reviewers. First of all, I would like to thank all the reviewers for their valuable comments, which enabled us to understand the work better. And let me thank. Now let me answer the comments. First of all, comments of Mikhail Nomovich Schneider. First of all, when negative ionization wave propagates, electrons come to the front from the cathode, and the positive wave spreads. Electrons form at the ionization front as a result of a more complex processes, photo processes. This leads to a higher different processes result to different speeds, velocities, and as for the second comment, in many studies, this return stroke, but this return stroke, how is it different from reverse breakdown? Is in the nature, in the return stroke. How does it start? The wave reaches a high voltage electrode, the tube is charged, the wave discharges the tube and goes in the opposite direction, and reverse breakdown wave moves exactly in the same direction as the primary, the wave of primary break. Secondly, the velocity, the speed of these waves are also very different. The reverse breakdown wave has the same speed as the primary breakdown wave, but a return stroke wave has a much higher speed. And as for and one more thing is important, the ionization wave created by reverse breakdown ionizes gas itself, and backstroke wave travels in the ionized gas. As for the third comment, I'd like to say such high voltage would result in electron run away, but this field is not constant. It exists only for a short moment, for a short period of time. So the electrons have, there's no time. Okay. Mikhail Aleksandrovich, are you satisfied with the answers? Thank you. Now, let me answer questions by Alexander Sergeyevich Smirnov. I accept all the comments. All modeling was purely electrotechnical, but it's not only electrotechnical but analytical, and this enabled us to obtain equations which gave us more evidence that we are right. And as for the parameter calculation, I'd like to say that it would be interesting to identify the parameters, measure capacity. Capacity can be measured by the length the wave travels at the initial point, once we know velocity. But as for resistance, yes, it's possible when modeling to calculate avalanche. Avalanche would require complex avalanche modeling, and so this modeling is would be very complicated. We would have to resolve the 3D problem, taking into account the features of all these processes. So our work was experimental. So that's the reason. That's all I had to say. Alexander Sergeyevich, are you satisfied? Yes, certainly. Thank you. Now, let me answer comments of Nikolai Leonidovich Aleksandrov. Here I'd like to say about the time interval. In case of short time intervals, it depends on space, radiation, artificial lights. This has been proved by the other authors, and processes occurring on the walls and on cathode. So these are similar to what's happening at short discharge intervals. As for this, your second comment, why the wave starts travel faster. When we have a screen, the wave does not accelerate because we have two electrodes. Their grounding effect is not much higher than that of the screen. And when the wave approaches the grounded electrode, the jump is insignificant. But let's look at the situation where the tube is not grounded, but we have this electrode. So what happens when the wave, while the wave travels inside the tube? But when it reaches the electrode is close to the ionization front, and power lines become locked to the electrode, and this generates strong field which makes the wave move faster, As you can see, with 3 centimeter size screen, this growth was even smaller. So in this, so that's the explanation I can give. A small comment about the last explanation. Can this effect be explained? Is this the same explanation or not? When you talk of power lines, in the line front there is charge. When it approaches a grounded metal electrode, it's induced as the charge is targeted on the opposite charge. The field becomes stronger and ionization field accelerates. Is this the same phenomenon? Yes, it can be explained from the point of charge. Charge is primary and the field is secondary. Thank you. I'm satisfied. Thank you. And questions by Yuri Borisovich Golubovsky. Let me answer comments by Yuri Borisovich Golubovsky. Why when registering lines in every separate impulse, we see impulses generated by separate photons. When we accumulate, get the same signal, electron hole diffraction. And so we have to get all the photon peaks recorded, and at the same time, the resulting signal formed by is averaging. It occupies a very small part of the oscillograph discharge grid, and as a result of this averaging, this happens. And this also gives us the answer to your second question. This discrete, they start at a different time. Starts where we see the first step of this impulse, but where this first stage starts, depends on it will. And moreover, we noticed one more interesting effect. The tube is long, and this effect cannot be recorded at a high voltage electron where the wave starts. So we are in the middle of the wave. We have a wave, and bright atom lines shine, and their light can reach the source of light. So they are registered first, because this light reaches light driver first, and while the wave is recorded only when it reaches the light driver, which it passes. So that means this effect can also be recorded at a distance, some distance away from the electrode. And about your third comment, ballast resistance, in case of ungrounded electrodes, of course, there can be no current, but impulse current, and this working with non-charged capacity. Of course, transistors have limits by impulse current and direct current, and the registration system with high potential registration system has its limitations as well. So to limit currents in the electric circuit, this ballast resistance is used. It also produces another interesting effect. Transistors have different resistance, channel resistance, which can be, so we need this primary reverse breakdown put in these same conditions. And that is why ballast resistance enables us to take more accurate measurements. Thank you, Sergei Aleksandrovich, Yuri Borisovich. Are you satisfied? Dear colleagues and guests, let us discuss the results of the presentation, all the presentation speeches. So I'm asking the board members, council members. So we have discussed the results of our discussions. Mikhail Naumovich, are you for? Yes, I'm fully for awarding the degree. Alexander Sergeyevich, Nikolai Leonidovich, Yuri Borisovich. I'm also for awarding the degree. So, out of 5 members of the Dissertation Council, all 5 voted for, no one voted against, nobody abstained. So, final word of the applicant. I would like to thank all my teachers and all the schools I've attended, and all the members of the Dissertation Council for reading my thesis, for submitting their reviews, for giving their time to attend this session. I would like to thank my academic advisor, my parents, my friends, all my teachers, starting with nursery school, and I would like to thank everybody who contributed to my success. Thank you, everybody. Thank you, Sergei Alexandrovich. So we would like to we are happy to award the degree of candidate of physics and mathematics, and we wish you lots of success in the future.